Every year, China produces more than 20 million tons of spices and seasonings, turning the country into the world's true flavor king. A place where just a few grams of ingredients can transform the taste of billions of meals across the globe. So what has allowed these tiny spice crops to build a massive industry worth over $100 billion every year? As we step inside China's gigantic spice industry, where endless fields stretch to the horizon, alongside processing facilities glowing through the night, where intense aromas of heat, richness, and pungency fill the air, while millions of tons of raw ingredients continuously flow through conveyor belts, trucks, and warehouses to fuel the flavors of billions of meals worldwide. At the first stop of our journey, we step into the Sichuan pepper capital of Sichuan province, a region that produces nearly 40% of China's Sichuan pepper output and generates billions of dollars in revenue every year. What many people don't know is that Sichuan pepper is not actually pepper at all, but a member of the citrus family, and it is the outer husk that creates its signature numbing sensation. This spice is best known in two major varieties: green Sichuan pepper, famous for its intense tingling effect, and red Sichuan pepper, which delivers a richer aroma, deeper flavor, and stronger heat. Behind this tiny spice lies an incredibly labor-intensive harvest process. Farmers must carefully reach through sharp, thorn-covered branches to cut each cluster by hand, before meticulously separating the thin outer husk, the very part that gives Sichuan cuisine its iconic soul. After harvesting, the Sichuan pepper husks are dried to become the soul of Sichuan hot pot. To create the famous spicy and numbing broth, massive blocks of beef tallow are first melted down before dozens of chili varieties, spices, and Sichuan pepper are added, releasing an intense aroma that can fill an entire kitchen within minutes. What makes this spice truly unique is not its heat, but the way it interacts directly with the nervous system. Instead of simply burning the tongue like ordinary chili peppers, Sichuan pepper creates a tingling, numbing sensation, as if tiny electric currents are running through the entire mouth. Once banned in the United States for nearly 40 years over fears that citrus canker bacteria could devastate agriculture, this spice, once considered a biological threat, is now experiencing a massive boom in restaurants across America. Few people realize that out of every 2 ginger roots consumed in the world, 1 comes from China. The country has at times accounted for more than 40 to 50% of global ginger production, and Shandong province alone is capable of supplying dozens of countries at the same time. Around August each year, China's vast ginger fields begin entering harvest season. To harvest ginger, farmers must use hoes to break apart the hardened soil and pull out massive clusters of ginger by hand, before quickly cutting away the stalks and leaves directly in the fields. Ordinary ginger is usually only palm-sized, but in China, some roots grow larger than construction bricks and nearly as long as an adult's forearm. In Shandong, there are even Ginger King competitions, where the largest ginger roots can sell for thousands of dollars. After harvesting, tens of tons of ginger are packed into massive cardboard boxes and loaded onto trucks before being transported directly to processing factories. There, the ginger is first washed and peeled to remove its outer skin, then cleaned again using high-pressure water systems before entering multiple production lines. Some roots are sliced thinly to make ginger candy for soothing coughs, while others are crushed and pressed into thick, intensely spicy syrup. With its warm aroma, mild pungency, and deep-spreading heat, ginger has long become one of the world's most famous spices for warming the body, fighting off cold conditions, and stimulating blood circulation. The world consumes so much Chinese garlic that around 7 out of every 10 kitchens on the planet are believed to be using garlic grown in the massive fields of Shandong and Henan. To the rest of the world, garlic may simply be a common seasoning, but in China, it has become a white gold mine worth more than $20 billion every year. During harvest season, entire fields transform into enormous manual production lines as thousands of workers continuously bend close to the ground, grip the stalks tightly, and pull each garlic bulb from the hardened soil. After being harvested, the garlic is lightly shaken clean and laid out in long rows under the sun to dry. It is then trimmed, with roots and leaves removed, sorted by size, packed into massive sacks, and loaded onto trucks bound for processing factories. Here, the garlic is continuously shaken to remove dirt, dried roots, and its thin outer skin. Powerful streams of air blow away the lightweight peel, while the cleaner garlic cloves continue through screening systems that remove damaged bulbs and impurities before workers carry out a final inspection. From there, the highest quality garlic is either dried or packaged as whole cloves for export. The remaining portion moves directly into the production line for China's famous sweet and sour pickled garlic. Along the conveyor system, a brine made from rice vinegar, sugar, and salt is pre-filled into glass jars before glossy white garlic cloves are dropped in continuously until each jar is packed full. The jars are then heat sterilized, sealed tightly, and transferred into fermentation rooms, where the garlic gradually turns golden, crispier, and richer in flavor over time. Leaving behind the garlic fields of Yunnan, the journey continues toward Henan, a region often called the Kingdom of Green Onions. Every year, this area produces more than 12 million tons of onions and scallions, accounting for nearly 40% of global output and helping China dominate the world's green onion market. This enormous scale has completely transformed the way onions are harvested in China. In large-scale farming regions, massive machines imported from the United States can move directly between the rows, using cutting blades and conveyor systems to lift entire lines of onions from the soil within seconds, before they lose moisture under the scorching heat. Because if left under the sun for too long, this surprisingly delicate vegetable can wilt faster than ice cream melting in summer. Right in the fields, the roots are quickly trimmed away to make the onions cleaner, lighter, and less likely to wilt during transportation. The onions are then sent directly to processing facilities, where thousands of high-pressure water jets blast away layers of dirt within seconds to preserve their natural green color and crisp texture. Along the conveyor lines, workers continuously remove wilted leaves and sort the onions by size before bundling them neatly together. Finally, the onions are dried using cold air systems and immediately transferred into refrigerated storage, ready for overnight container shipments traveling across Asia. As one of the very few vegetables in the world that can completely divide opinions, cilantro is loved by some for its distinctive aroma, while others passionately hate it because it reminds them of soap or even stink bugs. Yet despite all the controversy, millions of bundles of cilantro are still harvested every day from the seemingly endless green fields of Shandong. In China, cilantro is generally harvested in two ways: hand-harvested for the premium fresh vegetable market, or mechanically harvested on a massive scale to supply the seasoning and processed food industries. With manual harvesting, farmers must use small sickles to cut cilantro close to the roots in carefully gathered handfuls, because the stems are extremely delicate and the thin leaves can bruise or collapse after just a few strong squeezes. If handled too roughly, the aldehyde compounds inside are released intensely, causing the signature aroma to become overpoweringly sharp almost instantly. After harvesting, the bundles that retain the freshest green color and most stable aroma are quickly transported to processing facilities, where they are washed, trimmed, and packaged within just a few hours of leaving the fields. Meanwhile, in large-scale production fields, cilantro is harvested using specialized machines equipped with thin, high-speed rotating blades, fast enough to cut close to the roots while minimizing damage to the delicate leaves above. The harvested cilantro is then transferred directly onto conveyor systems for washing, dried with hot air, and ground into a fine green powder that releases a sharp, fragrant aroma almost instantly when opened. Today, this flavor has become a familiar seasoning base in many food products, exported to Europe, the United States, and the Middle East. Ranking among the world's most astonishing spicy food cultures, chili peppers in China have not only built an industry worth more than $100 billion annually, but have also become deeply woven into everyday life, appearing in meals, street markets, and countless pots of fiery red-hot pot, serving as the flame of flavor for billions of people. When harvest season begins, farmers do not pull chili peppers off the plants in bulk. Instead, they carefully select only evenly ripened red peppers, with tight skin and no cracks. Holding the stem gently, they twist each pepper at a slight angle before separating it from the branch, helping preserve the pepper's shape, prevent skin damage, and maintain its vibrant color before drying or processing. After leaving the fields, the chili peppers are not sent directly into grinding machines. Instead, they are first spread out in thin layers under the sun, so moisture can slowly evaporate. Once the skin turns a deeper shade of red and the spicy aroma becomes more concentrated, the peppers are gathered, loaded up, and transported straight to processing factories. At the factories, the chilies are poured into massive feeding hoppers and pass through vibrating screens and powerful air systems to remove dust, stems, sand, and remaining impurities before the entire batch enters sealed grinding systems. Inside the grinding chambers, the skin, seeds, and flesh of the peppers are rapidly broken down by high-speed rollers, while temperatures are carefully controlled to prevent color loss and the evaporation of spicy essential oils. Within just minutes, tons of red chilies are transformed into fine, evenly textured powder with an intense aroma. Beyond chili powder, China also produces massive amounts of chili oil by combining coarsely ground dried chilies with hot oil and various spices, creating the signature foundation of Chongqing hot pot, spicy Sichuan noodles, and countless Chinese dishes. At the final stop of our journey, we arrive at the sesame fields of Henan, the birthplace of the famous sesame oil industry that generates more than $12 billion for China each year. Across China's vast sesame fields, harvesting is now carried out using specialized combine harvesters capable of cutting the stalks, shaking loose the seeds, and collecting them directly into storage tanks in a single pass. This is especially critical because once sesame reaches full maturity, a strong gust of wind or an unexpected rainstorm can cause millions of dry seeds to fall to the ground within just hours. After harvesting, the sesame seeds are poured into massive washing tanks to remove dirt, dust, and remaining sand, before being quickly transferred into high-capacity hot air drying systems to eliminate all moisture prior to oil extraction. Once the seeds reach the ideal dryness level, the entire batch is roasted at temperatures exceeding 100 degrees Celsius, the crucial step that creates sesame oil's signature rich and nutty aroma. Finally, the roasted sesame seeds are fed into enormous hot press extraction systems, where streams of dark sesame oil begin flowing continuously like liquid gold before passing through multiple filtration layers that remove husk residue, sesame particles, and tiny remaining impurities. Following filtration, the oil is cooled to stabilize its color and preserve its distinctive roasted aroma, before flowing automatically into high-speed bottling lines. There, thousands of glass and plastic bottles are continuously filled, sealed, labeled, and packed into cartons within minutes before leaving the factory to begin their journey into millions of kitchens across Asia and around the world. During the Middle Ages, just 1 kilogram of pepper could be enough to trade for a cow. It once functioned as a form of currency in Europe, even used to pay taxes. And today, more than 500,000 tons of black pepper continue to move across the globe each year, powerful enough to shape the map of global trade. Pepper is not grown from seeds, but starts with healthy vine cuttings taken from a mature mother plant, typically 25 to 35 centimeters long and carrying 2 to 3 nodes. These cuttings are selected from plants over 3 years old, then planted in moist, organic, rich soil with humidity maintained at around 85%. After a few weeks, the dormant nodes begin to develop young roots and gradually establish themselves. Each seedling bag is then moved into a greenhouse, where temperature, humidity, and light are controlled with near hourly precision, allowing the plants to adapt and grow uniformly before being exposed to outdoor conditions. Once the vines are strong enough, they are transplanted beside living supports or concrete poles about 3 to 4 meters tall. From here, the pepper vines begin climbing, forming dense green columns that can produce stable yields after 2 to 3 years and continue bearing for the next 15 to 20 years. After about 7 to 9 months of growth on climbing supports, the pepper clusters are still mostly green, but a few berries begin turning yellow, a clear sign that harvest time has arrived. Because the vines can grow tall, farmers must use ladders or climb the supports themselves to pick each cluster by hand. Not due to a lack of machinery, but because a single strong shake could cause hundreds of unripe berries to fall to the ground and lose their value instantly. That seemingly manual precision is what ultimately determines whether the pepper will carry a bold, intense heat or end up as just an ordinary spice. Right after leaving the vines, the heavy sacks of fresh pepper are loaded onto trucks and leave the farm within hours, because if delayed beyond 24 hours, the berries begin to lose color and essential oils. On small farms, pepper is typically spread thinly across concrete yards or large tarps and turned continuously under the sun for 3 to 5 days. Simple, but entirely dependent on weather conditions. On larger plantations, however, the pepper is fed directly into steel receiving hoppers, passes through vibrating screens to remove stems, is washed to eliminate dirt, then moves into thermal treatment chambers before undergoing continuous forced drying in multi-level tower systems. In less than 48 hours, those soft green berries are transformed into tons of uniformly dried black pepper. More than 90% of people have believed that black pepper and white pepper come from different plants, but in reality, they both come from the same vine. The only difference lies in the timing of harvest and how they are processed afterward. In other words, they are simply two time-based versions of the same pepperberry. In contrast to black pepper, producing white pepper requires farmers to wait until the berries are fully ripe and red on the vine, when the outer skin has softened and natural bonds begin to break down, allowing it to be removed more easily and cleanly. As a result, the inner white core retains a deeper heat and a purer aroma. After harvest, ripe pepper is not dried immediately but soaked in water for about 7 to 10 days. During this time, natural microorganisms break down the outer red skin, softening it so it can be removed easily, leaving only the white kernel inside. This process not only cleans the pepper but also shapes its flavor. White pepper is milder, less bitter, yet still carries a deep heat and a distinct fragrance. However, the trade-off is significant. Waiting for full ripeness reduces yield, and the extended processing further lowers output by about 20 to 25%. As a result, white pepper typically costs about twice as much as black pepper on the market. So rare is it that in the United States, white pepper is only produced on a small experimental scale in Hawaii, one of the few places with a tropical climate suitable for producing export-grade pepper. As one of the 3 most expensive spices in the world, ranking just behind saffron and vanilla, cardamom has captivated global cuisine with its cooling taste and refined aroma, earning the title Queen of Spices. Unlike most spice crops, cardamom grows under the shaded canopy of humid tropical forests, more like a semi-wild plant than a typical farm crop. Once mature, these low-growing bushes can produce aromatic pods continuously for up to 15 years. After 3 to 5 years, the first pods appear near ground level and are harvested entirely by hand using small knives or scissors. A single rough pull can split the pods and cause seed loss, instantly reducing their value. Green pods are usually picked early to preserve their bright color and export quality aroma, while fully ripe red pods are far rarer, often reserved for propagation or specialty uses, as overripe pods can crack open and lose seeds within days. Once harvested, the pods must reach processing facilities within 12 to 24 hours. Any delay leads to rapid loss of essential oils and color. Instead of sun-drying, they are dried in temperature-controlled chambers to maintain quality. After drying, the pods are cleaned and graded by size, weight, and color. Only about 15 to 20% meet premium standards, while the rest are used for lower-grade processing or domestic markets. Just an unopened flower bud. Yet in the 16th century, cloves became one of the most powerful spices on earth, driving empires like Portugal and Spain to cross half the globe in a race for control. What made cloves so valuable wasn't just their rarity, but their warm, deep, slightly spicy aroma. Preserving that fragrance, however, requires timing that is precise, almost down to the day. Each harvest season, workers climb clove trees towering 10 to 15 meters high, securing ladders with ropes before hand-picking clusters of tiny buds within a narrow window of about 1 week. Harvest too early, and the essential oils haven't fully developed, resulting in a weaker aroma. Harvest too late, and once the buds begin to bloom, their commercial value drops sharply. Every movement must be exact, because breaking even a single branch can reduce yields for the next 2 to 3 years. After harvesting, the buds are separated from their stems, leaves are removed, and only the rounded heads, richest in essential oils, are kept. They are then sun-dried for about 3 days, turning from green to a distinctive golden brown. Too little or too much sunlight can darken the buds, degrade the oils, and immediately lower their value. That's why right after leaving the farm, high-quality buds are often transferred to industrial drying systems with controlled temperatures, reducing moisture to around 10 to 12%, locking in the precious oils that once drove entire empires across the oceans to claim them. And now we arrive at the king of spices, and also the most expensive spice in the world today, saffron, a national treasure of Iran. With prices often ranging from several thousand to nearly $10,000 per kilogram, saffron's value comes down to 3 core factors: entirely manual harvesting, extremely low yields, and a processing method that demands near-perfect precision. The saffron harvest lasts only about 6 weeks each year. During this brief window, farmers begin work at dawn and finish before midday, when strong sunlight can quickly wilt the flowers and degrade the delicate flavor compounds inside. Every strand of saffron is harvested by hand. Each flower is carefully plucked and placed into breathable baskets rather than sealed bags, because even slight compression or heat buildup can reduce quality almost immediately. Despite generating immense export value, the workforce, largely women in rural regions of Iran, often earns no more than around $5 per day for this highly meticulous and labor-intensive work. After harvesting, the purple flowers are quickly transported to processing facilities to prevent bruising. There, they are spread out in a dry, well-ventilated environment away from direct sunlight to preserve quality before entering the most critical stage, stigma separation. Each flower is opened by hand to reveal 3 deep red stigmas, the only part kept to produce saffron. This seemingly simple task is extremely labor-intensive. A skilled worker can extract about 600 stigmas per hour, meaning it takes roughly 40 hours of meticulous work to produce just 1 kilogram of high-quality saffron. To reach that amount, around 150,000 flowers must be harvested, an enormous raw material ratio that has earned saffron the nickname red gold. The red stigmas are then dried at low temperatures, reducing up to 80% of their moisture, while preserving their color and distinctive aroma. Once dried, they shrink into fine thread-like strands, the final product ready for packaging and export to global markets. Beyond its complex production and limited supply, saffron is prized in cuisine and traditional medicine for its mood-enhancing effects, antioxidant benefits, and support for better sleep. It adds a rich golden color and signature aroma to premium dishes with a slightly bitter taste followed by a warm, lingering fragrance. In the wake of African swine fever devastating the livestock industry, China has built massive pig skyscrapers, capable of producing more than 1 million pigs per year. But how do these high-rise pig cities actually operate behind the scenes? From herds of pigs living dozens of meters above the ground to highly automated systems running almost every part of the operation, this model is pushing livestock farming into an unprecedented era of industrialization. Today, let's step inside China's gigantic pig skyscrapers and see how an entire farming industry is being operated like a colossal machine running non-stop. After the devastating outbreak of African swine fever, which led to the culling of hundreds of millions of pigs and caused pork prices in China to surge, the country's livestock industry entered an unprecedented industrial revolution, raising pigs in massive high-rise buildings. Instead of traditional farms spread across vast areas of land, Chinese companies began constructing pig skyscrapers, apartment-like complexes for pigs reaching 6, 12, and even 26 stories high, with investment costs amounting to billions of yuan. These facilities are equipped with extensive automation systems, air filtration, waste treatment, and disease control technologies operating 24/7. One of the most well-known examples is located in Ezhou, featuring 2 26-story buildings capable of producing up to 1.2 million pigs per year, currently considered the largest high-rise pig farming complex in the world. Inside these pig apartment buildings, everything operates more like a high-tech factory than a traditional farm. Each floor is assigned a different stage of pig development: breeding, farrowing, weaning, fattening, and finishing before shipment. The fully automated feeding system transports food through sealed pipelines directly to each pen, allowing precise control of feed portions for tens of thousands of pigs at the same time. AI cameras and smart sensors monitor body temperature, movement, vocalizations, growth rates, and even abnormal behavior to detect illness at an early stage. Some farms even apply facial recognition technology for pigs, enabling extremely accurate individual tracking. Especially, even the movement between floors is mechanized, as pigs are transported via specialized elevator systems, functioning as part of an automated production line.
Come on out, little ones. Come on out.
Environmental technology is a critical part of the system. Air inside the buildings is continuously filtered through negative pressure ventilation systems, sterilized with UV light, and cleaned using biofiltration to reduce the risk of viral contamination. Workers entering the facility must go through multiple biosecurity checkpoints, change into protective gear, and undergo disinfection procedures similar to those in biological laboratories. Pig waste is collected through a closed-loop system and then processed into biogas for electricity generation or recycled as fertilizer. Thanks to this vertical design, land use can be reduced by 50 to 70% compared to traditional farming, a crucial advantage in densely populated areas with limited agricultural land in China. The biggest advantage of vertical pig farming is its scale and level of control. Within a single complex, companies can raise hundreds of thousands of pigs while requiring significantly less labor than traditional farms. Automation helps reduce feed costs, improves disease control, and accelerates growth rates by maintaining an optimized environment at all times. Large companies such as Muyuan Foods and Zhongxing Kaiwei even operate real-time data systems to adjust temperature, humidity, and feeding programs for each stage of pig development. A single worker can monitor thousands of pigs through computer screens instead of manually inspecting each housing unit. However, this model has also sparked intense controversy worldwide. Many experts worry that concentrating such a large number of livestock in a confined space could turn a small outbreak into a large-scale disaster if biosecurity systems fail. In addition, odor, wastewater, and noise from these mega farms place significant pressure on surrounding residential areas. Some residents living near pig skyscraper facilities in China have reported that they were forced to move away because they could not tolerate the smell and pollution. Animal welfare organizations have also criticized the system, arguing that pigs spend almost their entire lives in enclosed concrete environments with little natural light and limited space for movement. Despite the controversy, vertical pig farming is increasingly becoming a symbol of modern industrial livestock production. Instead of traditional sprawling farms, tens of thousands of pigs are now raised inside massive buildings that operate much like high-tech factories. From feeding robots and AI health monitoring systems to air filtration and waste treatment converted into biogas electricity, nearly everything is automated to optimize production at an extreme scale. In the future, these pig skyscrapers may become a familiar feature of the global livestock industry. When disease outbreaks occur in vertical pig farms, response measures must be carried out extremely quickly to protect the rest of the herd and prevent the virus from spreading. Pigs showing abnormal signs are immediately isolated for monitoring, while suspected infection zones are quickly locked down and continuously disinfected. For highly dangerous diseases such as African swine fever, which currently has no effective cure, infected herds are handled according to strict biosecurity protocols to safeguard the remaining livestock system. Afterward, barns and all equipment are thoroughly cleaned and disinfected before being brought back into operation. Because of these risks, modern farms are investing heavily in AI, sensors, and 24/7 monitoring systems to detect diseases as early as possible, minimize losses, and reduce the need for large-scale culling. In China, Ducks are one of the largest-scale livestock industries in the world, with hundreds of millions raised each year for both meat and eggs. In modern farms, ducks are often raised in massive flocks inside barns, stretching hundreds of meters long, where feeding and watering systems operate almost continuously throughout the day. After hatching, ducklings are moved into heated brooding areas to maintain stable temperatures before entering a rapid growth stage. Thanks to their fast growth rate and strong adaptability to wet environments, many meat duck breeds can reach market weight in just a few weeks. Meanwhile, egg duck farms can produce tens of thousands of eggs every day to supply China's enormous food industry. From salted eggs and century eggs to countless traditional dishes that use duck eggs as a key ingredient. However, in many agricultural regions of China, ducks are not raised solely for meat or eggs. Farmers also integrate them directly into rice fields through a system known as rice duck farming, a method that combines rice cultivation with free-range duck herding to reduce farming costs and limit the use of chemicals. After each harvest season, rice fields are usually left with scattered grains, empty husks, insect larvae, small pests, and snails hidden beneath the mud. Instead of letting these go to waste or relying on additional chemical treatments, Chinese farmers use duck flocks as a living biological cleaning system. Driven by their natural instinct to constantly dig through the mud for food, thousands of ducks move across the fields like natural cleaning machines, helping clear the land within just a few days. They feed on pests, reduce harmful insect populations, and are especially effective at controlling snails and young weeds, both of which could significantly affect the next rice crop. What makes this model highly valued is that it creates an almost complete economic cycle. Ducks take advantage of free food sources in the fields to gain weight naturally, while their droppings become nutrient-rich organic fertilizer for the soil. As the ducks constantly move across the paddies, they also stir the top layer of mud, increase oxygen levels in the soil, and help suppress the growth of certain weeds. Many regions in China that use rice duck farming, the integration of rice cultivation and duck raising, have significantly reduced their use of pesticides and chemical fertilizers while still maintaining high crop yields. This is also an extremely efficient economic model. In industrial livestock farming, feed is usually the largest expense, but with free-range field ducks, farmers can save a substantial amount of money by utilizing natural food sources in the paddies. A flock of ducks can be moved continuously across multiple rice fields throughout the harvest season, turning agricultural leftovers that would otherwise be considered waste into commercial meat and eggs. And in an era where livestock farming is becoming increasingly industrialized with robots, AI, and massive factory farms, China's rice duck farming system still represents a very different approach. One where thousands of ducks not only produce food, but also directly participate in the operation of traditional agriculture itself. Besides pigs and ducks, China also has a livestock industry that may sound small in scale, but is actually enormous: quail egg farming. China is currently one of the world's largest producers of quail eggs, with billions consumed every year in street food, hot pot dishes, instant noodles, packaged snacks, and the processed food industry. Although quail eggs are only about 1/5 the size of chicken eggs, they have become a common ingredient throughout China's food industry, thanks to their compact size, easy preparation, and extremely short production cycle. Quail farming operates much like a miniature industrial production line. After hatching, baby quails are moved into heated brooding areas equipped with warming systems and continuous lighting to maintain stable temperatures. Since this is the stage when the birds are still fragile and highly sensitive to environmental conditions, within just a few weeks, they enter an extremely rapid growth phase before being transferred to egg-laying facilities. Due to their small size, quail housing systems are often designed as multi-tiered cage rows, stretching dozens of meters long, allowing an enormous number of birds to be raised within a relatively compact space. Automated feeding systems continuously distribute feed along long troughs, while water is supplied through drip-style drinkers to minimize waste. Lighting inside the facilities is also carefully controlled, since the duration of light exposure directly affects the quail's egg-laying performance. One of the most remarkable aspects of quail farming is the nearly non-stop rate of egg production. Once they reach peak productivity, tens of thousands of quails can produce a massive quantity of eggs every single day. After being laid, the small eggs roll out of the cages and automatically slide onto conveyor belts below, where they are transported to sorting, cleaning, and packaging areas that operate almost entirely through automation. At large-scale farms in China, the entire process, from feeding and egg collection to waste management, is optimized to minimize labor costs and maximize production speed. However, because quails are raised at extremely high densities, environmental control becomes a critical factor for survival and productivity. Even slight temperature fluctuations or excessive humidity can quickly stress the flock and reduce egg production. As a result, many facilities operate ventilation systems almost 24 hours a day to reduce dust, ammonia buildup, and maintain stable air quality inside the barns. Quail manure is also collected continuously because, at a scale of hundreds of thousands of birds, the amount of waste generated each day is enormous. Compared to conventional laying hens, quails consume far less feed, but begin laying eggs at just over 1 month old, a speed that makes them one of the fastest return livestock species in the poultry industry. While many chicken breeds require several months before reaching stable egg production, quails grow extremely quickly and can produce eggs almost daily once mature. Their small size also allows farmers to significantly reduce housing space, feed consumption, and operating costs. As a result, the number of quails raised within the same area can be far higher than chickens, creating an exceptionally dense level of egg production. This is why many people describe modern quail farms in China as mini egg factories, operating almost non-stop throughout the day. First, we arrive at Zikang village in Zhejiang province. This small village of only about 1,000 residents may look peaceful, but it hides a nightmare for many people around the world. More than 3 million snakes of various species live together in less than 1 square kilometer, accounting for up to 10% of the country's total snake production. Can you guess what makes the locals willing to live alongside snakes? In fact, a professional snake farming household can earn between $55,000 and $68,000 per year, making snake farming a highly sought-after occupation in rural areas. The process begins with female snakes that reach the standard age of 9 to 10 months. To optimize the survival rate of the brood, farmers apply a controversial but crucial intervention technique: stitching the snake's lips with fine thread when the egg-laying season begins. The purpose of this is not to protect humans, but rather a technical measure to eliminate the female's instinct to eat their own eggs. With a yield of 12 to 21 eggs per clutch, manual collection must be carried out strictly every 2 hours. However, this is an extremely tense and dangerous period, as the mother snake remains in a defensive state, ready to strike at any moment. Collectors use a wooden stick with a metal hook at the end to skillfully lure the mother snake away from the nest. The operation must be fast, precise, and extremely cautious. Courage alone is not enough, as the price to pay could be a fatal bite from a highly sensitive mother snake. Moreover, even a slight delay can cause the embryos to die due to changes in temperature and humidity, rendering all the care efforts meaningless. Once removed from the nest, the eggs are taken to the incubation room. There, technicians inspect them using a flashlight to check embryo development and detect abnormalities. Qualified eggs are placed into incubation trays with strictly controlled temperature and humidity, while any discolored or irregularly sized eggs are immediately discarded. As they enter the growth stage, the snakes are transferred to standard cement enclosures measuring 0.5 meters in height and 1 meter in width, reinforced with sturdy steel mesh. Here, they are provided with a high-protein diet consisting of frog meat or baby chicks, fed 2 to 3 times per week. A 1-month-old group of snakes can consume up to half a kilogram of baby frogs per day to ensure rapid muscle development and the accumulation of high-quality venom. For individuals that absorb nutrients poorly or refuse to eat, farmers carry out a force-feeding process by using a stick to place food directly into their mouths, ensuring the entire group reaches the required weight before harvesting. This level of strictness is the foundation behind the immense economic value of the final products. In specialty restaurants, snake meat is prepared into stews or soups, priced between $50 and $100 per kilogram, depending on the species. In addition, snake wine remains an iconic product in traditional East Asian medicinal culture. Jars containing whole cobras or banded crates can sell for up to $1,000, based on the belief that they enhance vitality and help treat joint-related conditions. Leaving the snake farming village in southern China, more than 27 million buffalo are undergoing a major genetic transformation. For decades, this animal was shaped for labor rather than economic value. They were mainly used for plowing and freely grazed on river floodplains or steep hillsides. This farming method relies on a unique biological mechanism. Buffalo must soak in water or mud for 2 to 4 hours each day. With an extremely limited number of sweat glands, wallowing is almost the only way for them to regulate body temperature, remove parasites, and protect their skin from harsh heat. However, this nature-dependent farming approach is gradually being restricted due to strict government regulations on resource management. Large-scale free grazing has been limited in many areas to prevent forest soil erosion, protect biodiversity, and especially to eliminate the risk of water pollution caused by livestock waste. It is precisely these environmental constraints that have driven a shift toward high-tech, intensive farming models. By crossbreeding local buffalo with imported breeds such as Murrah and Nili Ravi, experts have increased milk yields from 500 kilograms to 2,500 kilograms per cycle, transforming an outdated draft animal into a true money-making machine. In Guangxi, the buffalo milk capital supplying up to 60% of the nation's total output, buffalo are no longer free-grazed but are instead raised in large-scale facilities with temperatures maintained below 30 degrees Celsius. This controlled housing, combined with automated TMR, total mixed ration feeding systems, ensures complete consistency, producing premium milk valued at up to $6 per liter, 4 times the price of cow's milk. The reason buffalo milk can command such high prices lies in its superior biological properties. It contains twice the fat yet less cholesterol than cow's milk. Notably, with 58% more calcium and 40% more iron, along with A2 protein that is easier to digest, buffalo milk has become an ideal alternative for children, the elderly, and those sensitive to lactose. In Luan City in eastern China, hundreds of millions of geese are quite literally laying golden eggs, producing hundreds of thousands of tons of feathers each year, an economic value that rivals that of their meat. Leveraging its dense freshwater ecosystem, China has come to dominate this entire industry, controlling up to 90% of global meat production and 80% of the global feather market share. The journey of a goose begins in industrial hatcheries, where temperature and humidity are precisely controlled. After collection, goose eggs are carefully inspected under light before being placed into incubators. After about 28 to 35 days, goslings hatch from the selected eggs, healthy and ready to begin a new life cycle. They are then kept warm, carefully nurtured, and provided with adequate nutrition to ensure stable development. However, for young poultry, the brooding stage is extremely sensitive. Without proper control of temperature and hygiene, goslings can die in large numbers due to disease or thermal shock. As waterfowl with high activity needs, geese require ample space to develop feathers that meet quality standards. As a result, farms in Luan typically combine enclosed farming systems with large natural water areas. After about 120 days, when they reach a weight of 4 to 6 kilograms, the feathers achieve the necessary elasticity and insulation, key criteria that unlock a multi-billion-dollar value chain. By controlling the neck, the most maneuverable part of the body, workers can quickly separate each goose from the flock and place it into transport cages, while keeping the feather structure intact and undisturbed. From there, at the factory, the feathers undergo a rigorous industrial processing line. Raw feathers are separated using airflow to classify them by weight, then pass through a series of washing, sterilization, and centrifugal drying processes to completely remove impurities and moisture. Finally, they are dried and fluffed to achieve maximum loft before being inspected and precisely filled into premium bedding products, where goose down offers superior insulation and is significantly lighter than duck feathers of the same weight. But it doesn't stop there. Goose feathers have also unlocked another billion-dollar market: badminton shuttlecock production. Few people know that to create a shuttlecock that meets international competition standards, exactly 16 nearly identical wing feathers are required, carefully selected from the healthiest mature geese, an essential factor in achieving a stable flight trajectory that synthetic materials still cannot fully replicate.
See that seam right there?
No longer confined to the ground, China's livestock industry has expanded skyward, where more than 600 million pigeons operate like mobile protein production lines, ready for market in just 21 days and delivering economic efficiency 3 times higher than traditional farming. In multi-tiered cage complexes stacked high to the ceiling, the key to this ultra-fast capital turnover lies in the 2+2 model combined with artificial feeding. In nature, parent pigeons must produce crop milk to feed their young, a process that consumes significant energy and prolongs the reproductive cycle. Chinese agricultural engineers have overcome this biological limitation by allowing parents to raise the chicks for the first 7 days, then separating them and transferring them to automated feeding systems. With the support of technology, a nutrient mix that perfectly mimics crop milk is directly injected, allowing young pigeons to increase their body weight 8-fold in just 3 weeks. By removing the burden of parental feeding, adult pigeons can immediately enter a new egg-laying cycle, boosting productivity from around 10 broods to 25 to 30 chicks per year. As a result, meat pigeons reach market standards in less than 1 month. Do you know how thousands of pigeons are transported at once without losing a single one? This is where specialized ventilated trucks come into play, tightly packed with stacked plastic cages, maintaining a massive supply flow from high-rise farms directly to centralized slaughter lines within just a few hours. Beyond providing ultra-fast protein, internal organs such as pigeon liver and heart are often valued up to 5 times higher than regular white meat due to their concentrated iron and micronutrient content. Especially the liver, one of the richest natural sources of iron in the food world. In some premium markets, they are even sought after as animal ginseng, although this term is more rooted in folklore than science. Moving into the inland waters of Zhejiang province, you are faced with a massive biological gemstone factory, one that controls up to 95% of the global supply of freshwater pearls. At the core of this system lies a breakthrough technique: multi-point mantle tissue grafting. Unlike saltwater pearls, where each oyster is implanted with a single solid nucleus, technicians here make dozens of ultrafine incisions in the mantle of a living mussel, then insert epithelial tissue taken from another individual without using a hard nucleus. As a result, each mussel no longer produces just one pearl, but becomes a multi-point production system, capable of cultivating 30 to 50 pearls simultaneously in a single cycle, increasing output density dozens of times compared to traditional methods. To ensure consistent quality at an industrial scale, the entire living environment is tightly controlled. Instead of resting in unstable bottom mud, millions of mussels are suspended in mesh bags within oxygen-rich water layers, where growth conditions are continuously optimized. At the same time, biological sensor stations spread across the lake monitor algae density, the primary food source, in real time, maintaining a stable and optimal nacre secretion state, which directly determines the luster and color of the pearls. After 3 to 5 years of nacre accumulation, the mussels are harvested and manually opened with precise incisions to release large quantities of pearls, ranging in color from milky white to pinkish purple. The pearls are then sent through a surface treatment line, where they are cleaned and polished using ultrafine abrasives, such as aluminum oxide powder or industrial diamond powder, creating a near mirror-like luster before entering the grading stage. This is the most labor-intensive phase, as thousands of workers must sit for hours to manually sort millions of pearls based on size, shape, roundness, and reflectivity, factors that directly determine their commercial value. With its concentrated calcium and amino acid content, Chinese pearl powder can retail for up to $200 per 100-gram jar when packaged as a premium cosmetic ingredient in the US market. Beyond that, even the shells left after pearl extraction are ground into mineral additives for animal feed, ensuring the entire system operates under a single principle: not a single gram of material goes to waste. On the international market, Chinese pearls have the advantage of low prices thanks to large production volumes and a wide variety of designs, making them highly accessible. However, their quality is often inconsistent, with luster and durability sometimes inferior to pearls from Japan or Australia. In contrast, other countries focus on higher quality, but their products tend to be significantly more expensive.